we need to find the value of x for the given logarithmic equation. So let us begin. So on the left hand side, we have two logarithm, log of 3x plus 2, and this is added to log of 3x minus 2. Now these two logarithm can be combined to form one single logarithm. If we use the property, that means if we have log of a and this is added to log of b, so that was equals to log of a times b. Right? So let's use this property and we should get log of, so we have 3x plus 2. This is multiplied to 3x minus 2, and that's equals to 5 log of 2, and 5 log of 2 can be also written as log of 2 raised to the power of 5. Here we have used the fact, that means if we have a times log of b, so that's the same as log of b raised to the power of a. Now let's do further simplification. So 3x plus 2 multiplied to 3x minus 2, that should give us 9x squared minus 4, and this is equals to log of 2 raised to the power of 35, so that's 32. Now when the base of the logarithm is not provided, by default it's assumed to be equals to 10. Now that we have two logarithm of same base on both sides, we can equate them to get rid of the logarithm and rewrite as 9x squared minus 4 as equals to 32. Or simply 9x squared equals to 36, or x squared equals to 4. Now here x can take two values, plus 2 and negative 2. But we know that if we have a logarithmic function log of x, then this is defined only when x is greater than 0. It's going to be undefined for all the values of x less than or equals to 0. So it's undefined even at x equals to 0. So that means x cannot take the value negative 2. Final solution will be x is equals to positive 2. So this is a solution to a given logarithmic equation.